Alright, next question in the radical and rational unit, how to solve a rational equation. So we've looked at the intersection method, now we're going to look at the x-intercept method. So what you want to do is just put this in your calculator as y1. You'd have 2x squared plus 3x minus 1 over x minus 1. Put that in big brackets. Then we're going to subtract in large brackets 4x plus 5 divided by x squared plus 3. Okay, so we'll go ahead and put that in our y equals. Okay, so 2x squared plus 3x minus 1, and that same set of brackets divided by x minus 1. Close the larger set of brackets. Now we're going to subtract over 4x plus 5. Notice the double bracket. Close the numerator. Now divide by x squared plus 3. Close both sets of brackets. And oh, I forgot one bracket here. So just insert a bracket. Okay, now we can go ahead and graph. Now the solutions we see will be where the graph is crossing the x-axis. Okay, so right here. And if I were to go a little bit higher, I would see another piece. Let's just increase the window settings. Y max. Put it to 20, hopefully we can see it then. Okay, there we go. So this is just giving the general shape of the graph, but if we're asked to solve this, what we're looking for are these x-intercepts. Okay, so I didn't need to see this, I just wanted to show you what the graph looked like. So if we want to find the x-intercepts, let's just zoom in a little bit closer. I'm going to go to y max at 5. Okay, using our trace feature, second trace, number 2 for zeros. Second trace, number 2. Okay, left bound, enter. Right bound, enter. And enter again. Okay, our first x-intercept right here is at negative 0.25. Maybe I'll just draw this graph so you guys can see it on here as well. So this first one is negative 0.25. Now we'll trace our second x-intercept. Second trace, number 2. Okay, you're going to go left bound, which is below the x-axis, press enter. Right bound, which is above the x-axis, press enter. Enter again. And we are at negative 2.08. Okay, so x equals negative 2.08 and negative 0.25. Easy as that. Okay, now if we're asked the nearest tenth, negative 2.1 and negative 0.3. Make sure you're reading carefully what you need to round to. Okay, so one of the skills you need to know for the rational functions unit is how to find the restrictions. Okay, where will be your non-permissible values? That comes from your horizontal asymptotes, your vertical asymptotes, as well as points of discontinuity. Now, horizontal asymptotes, there's 3 different rules. So, if the degree of the numerator is bigger than the degree of the denominator, then the horizontal asymptote will not exist. None. If the degree of the numerator is equal to the degree of the denominator, then you're going to take the ratio of the coefficients, A over B. So just a quick example. Say you had the rational function 2x cubed over 5x cubed minus 4. Okay, degree 3, so they're equal. The ratio for the horizontal asymptote would be y equals 2 over 5. The last rule is if the degree of the numerator is less than the degree of the denominator. In that case, your horizontal asymptote is y equals 0. Okay, when we're looking at vertical asymptotes, we always are looking at what is the restriction on the denominator. Okay, so the non-permissible value of the denominator. And we can see right here, if we're dividing by x minus 4, okay, imagine this was just 1 over x minus 4. Okay, your non-permissible value would be that x cannot equal 4. So what would be the equation of the vertical asymptote? Well, your vertical asymptote would be x equals 4. Okay, now points of discontinuity, they come from examples where you factor and then you see factors cancel out. Okay, so with points of discontinuity, first you want to factor, and then any factors that cancel out define a point of discontinuity. P of D, point of discontinuity. Okay, and we're going to take a look at how to find points of discontinuity in this next example. Okay, so step 1, in order to simplify a rational expression, we need to factor it first. Ultimately, we're going to be solving for the domain and range by identifying what are the horizontal asymptotes, what are the vertical asymptotes, and how to find a point of discontinuity. Okay, so number 1, let's factor. So we have y equals x squared minus 5x plus 4. Two numbers that multiply to 4 but add to negative 5. Okay, would be negative 4 and negative 1. As you can see, we have two common factors in the numerator and denominator. So step 2 would be to cancel out common factors. Okay, so the x minus 4 is going to cancel out. And we're left with y equals x minus 1. Well, that's just a line. X minus 1 is just a line. But we can't forget that there was a discontinuity. There was a non-permissible value, and that was x cannot equal 4. Because these factors canceled out, that also tells us that we have a point of discontinuity, and that's going to occur when x equals 4. So how do we find the full point? We know the x-coordinate is 4. Now we need to solve for the y-coordinate. So what we need to do is go from y equals x minus 1, the simplified form. We're going to sub in the point for where we have that point of discontinuity. So sub in that x value, and that's going to give us the y-coordinate. So y equals, sub in 4, minus 1, and y equals 3. So the point of discontinuity occurs at 4, and instead of y here, I'm going to put a 3. So what is our domain? Well, x cannot equal 4. Other than that, x is all real numbers. And what is our range? Okay, well, let's take a look here. The degree of the numerator was 2. The degree of the denominator was 1. So going back to our rules, if the degree of the numerator is bigger than the denominator, no horizontal asymptotes. But as we can see, there was a point of discontinuity at 4, 3. Therefore, y cannot equal 3. Other than that, y is an element of all real numbers.